Okay, so these two examples I'm going to do with you guys are actually really similar to the practice problems that you're going to do out of the book a little bit later. So let's get right to it. Example one's right here. I'm going to let you guys pause the video and write this down in your notes because after this I'm going to flip to the whiteboard. So it says find two positive numbers whose product is 192 and whose sum is a minimum. Okay, wherever it says minimum or maximum, that's your optimization equation, right? If you're looking for a minimum or you're looking for a maximum, that's your optimization equation. Optimization, okay? And then whose product is 192, whenever you're given some target that you have to hit, that's your constraint. Okay? That's your constraint equation. Okay? So just think about it. You have a product of 192, right? Okay, and you don't have to do this on every problem, just kind of explaining what this all means. But if you have two values, let's just say an x and a y, who have to multiply together to be 192, you could use 2 and 96, you could use 3 and 64, you could use 4 and 48, you could use 6, you could use 8. All these things multiplied together are going to be 192, but you want to pick the two numbers whose sum is a minimum, okay? So that's why we're putting our two equations together. We have a constraint, we have an optimization, okay? So let me just set this aside for now, and I'm going to pull down, we're going to have two equations here. We're going to have a constraint equation, which is our product is 192, okay? So I'm going to say x times y equals 192. And this is, you're going to have a constraint and optimization on every single one of these problems, okay? And then the optimization equation, if you guys look back at the problem, it says whose sum is a minimum, okay? So that means if we're summing, so we're adding, so if we add those two numbers together, we need to come up with a sum that is a minimum, okay? So again, two equations and two variables, okay? You have an x and a y. I know we're looking at this s here. That just means sum. That'll come into play a little bit later. Let's not worry about that for now, okay? So first step, get your optimization equation into one variable. So you have an x and a y, okay? So we're always going to go back to our constraint equation to solve for one of our variables. So I'm going to say y equals 192 over x. Okay, so that tells me y in terms of x. Okay, so that's going to help me rewrite my optimization equation. And actually, let's do this. Just so we know that this is the same thing. 192 over x is the same thing as 192 x to the negative first. Right? Those two mean the same thing. Okay, so if I take this back into my optimization equation, which is step 2 on your steps, we have x plus, and instead of writing y, I'm going to write what y is. So 192 x to the negative first equals our sum. Okay, or you could write 192 over x. I use the negative 1 because eventually we're going to be taking the derivative, and it's just easy to have powers when you're taking the derivative. Okay. So now we want to find the optimal value, so which means we need to find the critical point of this optimization equation. Okay, so critical points obviously mean we're going to be setting the derivative equal to 0. So I'm going to take the derivative of this. Okay, so I'm going to say s prime is equal to 1, because the derivative of x is 1, minus 192 x to the negative second. Okay, so that's the derivative. So if this is our sum, s prime takes the derivative of that. Okay, so to find our critical point, we set our derivative equal to 0. So I'm going to say 1 minus 192 over x to the second equals 0. Okay, it's just easier for me to solve for x, I think, this way, rather than having a negative exponent. So this is going to be negative 192 over x squared equals negative 1, right? Because I could take this negative 1 and I can bring it to the other, or I can take this 1, subtract it, and bring it to the other side to make it negative 1. Okay, let me just slide this up. Okay, So when I solve for x, if I multiply by x squared on both sides, x squared, okay, by the time you end up solving for x, x comes out to the square root of 192, okay, which when you do that in your calculator, it comes out to like 13.856 dot dot dot. So let's just leave it as the square root of 192, okay? So this is our optimal x value, okay? That's our optimal x value. The problem says that we want to figure out where the sum is a minimum, okay? So the one thing that we need to do is check the second derivative, because the second derivative is going to tell us, is it concave up or is it concave down? It should be concave up if it's a minimum, right? Okay, so I'm going to say s double prime is equal to, let's go all the way back up to, I'm just looking at my first derivative here. This is my first derivative, okay? If I take that down here and take my second derivative, and you guys can look back at your notes, but second derivative, I'm going to go negative 192 times negative 2 is 384 over x to the third, okay? If I were to take my x and plug it into here, 384 divided by the square root of 192, that is still greater than 0. And if it's greater than 0, we know that our graph is concave up, which means we have our minimum, okay? That's just, this second part where we're taking the second derivative is just a check, okay? The problem asks us to find where the sum is a minimum, okay? So by taking the second derivative and taking your x and plugging it in, 384 divided by square root of 192, that's going to come out to a number greater than 0, which means we're concave up. And this goes back to curve sketching, okay? This is always going to work in all of your problems. You're never going to take the second derivative and figure out and find that, you know, it goes in the wrong direction. For the purposes of this lesson, it's always going to go in the right direction. This is just a check to show that you're at a minimum, okay? So we found our x value, but it asks us to find our x, our two values, our x and our y values. So I'm going to take that x and plug it all the way back up here to y. So y is equal to 192 over the square root of 192, okay? By the time you do that in your calculator, you get the 13.856 dot dot dot, which is the same thing as square root of 192, okay? So the two values whose product is 192 and whose sum is a minimum is, here's your y, and here's your x, okay? So let's do one more example together, okay? So let our second example be, and I'll let you guys write it down for a minute here. So it says find two positive numbers whose sum is 54 and whose product is a maximum, okay? This is your constraint. Product is a maximum. Remember, if we're finding maximum or minimum values, that's our optimization equation. So we have a constraint equation, we have an optimization equation, okay? So let's set these up. Our constraint, it says a sum is 54, okay? So we're going to write x plus y equals 54. And then our optimization equation says whose product is a maximum. So product means we're multiplying two numbers together to get a product. Okay, so this one's a little bit different. We're doing products as our optimization instead of sums. Okay, all right. So let's do this. It says, so I'm going to take my y and set it equal to 54 minus x. Okay, so that way I can take this over to my optimization equation and say x times 54 minus x is equal to p. Okay, this is like the crucial first step in optimization, getting your equations into one variable. Okay, so I'm going to leave my y right the way it is. I'm going to come back to it at the very end when I'm solving for y. And I'm going to solve for x here. So I'm going to say, or not solve for x, but I'm going to distribute the x. So it looks like this. Okay? All right. So now to find the optimal amount, we have to take our derivative, set it equal to 0. So I'm going to say 54 minus 2x equals 0. Okay? So when I'm solving for x, I go minus 54 from both sides, minus 54 from both sides. I get negative 2x equals negative 54. Okay? So then when I divide by negative 2, I get x equals 27. Okay? So x is equal to 27. Let's just do a quick check and make sure that the product is a maximum. Okay? So if I take my derivative and I take it another time, so I'm going to find my second derivative, okay, that would be 54. I'm sorry, I'm looking at the wrong one here. Let me just jump back. This was my derivative. Okay? So my second derivative is going to be negative 2. Okay? And negative 2 is just a number, but it's a negative number. Okay? And that negative number is less than 0. Okay? So if it's less than 0, that means we are concave down. Okay? Which is good because we want the product to be a maximum. It means we need it to be at the top of this hill. Okay? So that check works. Okay? So we have x is 27. Now we just have to find what y is. Okay? So I'm going to jump back and say y equals 54 minus x, which was 27. So y is equal to 27. Okay? So we have our x and we have our y. Okay? All right, so here's what I'm going to do. I'm going to give you guys one U-try problem. So an example problem for you guys to try on your own. And what I'll do is I'll post the answer key to this U-try problem on Google Classroom. So I would say give this one problem a try that I'm about to give you right here before you start your practice problems, because this is going to show you hopefully whether or not you have a good handle on this. So here's our U-try problem. Again, pause the video, write it down, try it on your own. The answer key will be posted on Google Classroom. Again, ask me questions, guys. Reach out if you're struggling with this stuff, and just let me know.